A student club is comprised of 36 female students and 24 male students. The club president wants to break the club into groups. He would like to make sure that each group has the same number of female students and that each group has the same number of male students. For example, he could break the club into 2 groups, and each group would have 18 female students and 12 male students. Use the table below to list all of the possible groupings that the president could use. For each grouping, include the number of groups, the number of females in each group, and the number of males in each group. The first row has been completed for you. First, let's take a look at the first row and make sure we understand where we're getting the number of groups and where we're getting the number of female students and the number of male students. Okay, let's say we wanted to break the club into 2 groups. Well, if we have 36 female students and we break them into 2 groups, each group would have 18 females. If we have 24 male students and we break them into 2 groups, each group would have 12 male students. So we're taking the total number of female students and dividing it by the number of groups, and then we're taking the total number of male students and dividing it by the total number of groups. So the only way for this to work is if the number of groups is a factor of both 36 and 24. So we need to figure out what other numbers can go in that column for number of groups. So what we need to do is we need to figure out all the factors of 36, and we need to figure out all the factors of 24, and then we need to see what numbers they have in common. So let's first make a list of all of the factors of 36. So obviously 1 and 36 are factors of 36, and then we're going to go in order from the number 1. So after 1 comes 2, and that would be paired with 18. After 2 comes 3, which would be paired with 12, and then 4, which would be paired with 9. Now, just to keep in the order of 1, 2, 3, 4, 5, I put a 5 there, but 5 is not a factor of 36, so 5 would not have a partner. So I'm going to erase the number 5. 6 would come next, and its partner would be 6. After 6, I could try 7, but 7 is not a factor of 36. I could try 8. 8 is not a factor of 36. 9 would come next, but since I've already accounted for the number 9, it means that I'm done. I've exhausted all possibilities and I've found every factor of 36. So that table is all my factors of 36. Let's do the same thing for 24. Obviously, we'll start our table with 1 and 24, then 2 and 12, 3 and 8, 4 and 6. After 4, we would try 5, but 5 is not a factor of 24, so we would erase 5. We could try 6, but we've already accounted for 6, so as soon as we see that repeat, we know that we've completed our list. Alright, so let's write these out in numerical order. All the factors of 36 are going to get lined up from smallest to greatest, and all the factors of 24 are also going to get lined up from smallest to greatest. What we want to do is we want to look for the factors that they have in common. Now, they have the factor 1 in common, but that doesn't help us because that would just mean the club is one big group, which means he hasn't split them into any groups. We could split them into 2 groups. That was the example you saw on the other page. We could split them into 3 groups, 4 groups, 6 groups, or 12 groups, because those are the factors that the number 36 and 24 have in common. Since we've already done 2 groups as the example, we're going to start with 3 groups, and then we will do 3, 4, 6, and 12 groups. So we've determined that the common factors are 3, 4, 6, and 12. So those are going to be the different numbers of groups that the club president can divide his club into. So if he divides it into 3 groups, that would mean there would be 12 female students and 8 male students. If he divides it into 4 groups, there would be 9 females and 6 males. And then we'll continue for 6 groups. So if it was 6 groups, there would be 6 female students and 4 male students. And if there were 12 groups, we would have 3 females and 2 males in each group. So the question in part B is asking us, what is the greatest number of groups the president can create? Well, that would be 12, because that is the greatest common factor between 36 and 24. And that those groups would have 3 female students and 2 male students in each group. So the greatest number of groups the president can create is 12. Now I just want to make sure that we caught that earlier, what I just said. The number 12 is also the GCF, or the greatest common factor, of 36 and 24. So that's why it's the greatest number of groups that the president can create.